DJD Academy. This is Anil, Faculty of Digital Electronics. Today I would like to take one concept called full adder implementation or construction of full adder with the help of off adders. Let us see how to construct it, and this is what very important bit in competitive exam point of view. How many number of off adders and other gates are required to implement one full adder? This is what important question. Let us see. Sir, we have seen already how to construct off adder and how to construct off subtractor and how to construct full adder also. We know that what is the equation of full adder. Sir, let me take a point called here construction or implementation of full adder with half adders. Let's see how it is possible. Sir, we know that full adder. Can you please just tell me, can anybody tell me what is the number of inputs for full adder? We have 3 inputs and 2 outputs, which are here. We know that inputs of full adder are 3, which are A comma B comma C. And now outputs of full adder, we know that first one is sum and then second one is carry, COT. C out we can implement because here we are mentioning A, B, C is the input, so that just for the difference sake, to understand better and to not to confuse that this particular C and this particular C both are not same. This is what C input and then this is C output. I mentioned here C out. So these are the inputs and outputs of full adder. Can you please just tell me what is the output of sum? Here output of sum SUM equal to, we know that A XOR B XOR C is the sum output. We have seen already. And then can anybody tell me what is the carry output of full adder? C out equal to, we have already seen in the previous lecture. We know that this is what AB plus S, A XOR B into C. This is what carry output. This is carry output and this is sum output. Let us try to prove these two outputs. Let us try to implement these two outputs with the help of 2 off adders or 2 off subtractors by using NAND gates, NOR gates, whatever it is. Let us try to prove. Now, as a point of review, let us try to implement these 2 outputs with the help of off adders. Sir, we know that off adder class also we have seen. Let me draw the off adder here. Off adder. We know how to draw off adder. And now half adder is having inputs. We can say 2 inputs, which are A comma B, and then outputs of half adder are, we have 2 outputs. First one is sum and then second one is C out carry. And now can anybody tell me what is the sum expression? We know that we have sum output is S equal to A XOR B. This is what sum output of off adder. And what is the carry output? C out equal to, we can write it as A into B. This is what carry output. Now let us try to understand the important concept. This is a very important concept, very important point in competitive exam point of view. Sir, let me draw off adder first. We know that off adder, here to implement sum output, this is sum output S equal to A XOR B. Let me take, this is A and this is B, 2 inputs. Here this is one XOR gate. Can I say that this is what A XOR B output? Yes sir. XOR. This is what S output equal to A XOR B. Yes. Now let me take this one. C out, carry output is like this. What is the carry output, sir? Here let me take a connection from here A, and then let me take another connection from here, and I want to take one AND gate between A and B, so that this will become AND gate carry output C out equal to A into B. This is on half adder. And now let us try to implement one more thing. Sir, here to implement full adder, we have three input variables which are A, B, C. And now coming to half adder, we have only two input variables which are A, B. So I need to take one more input variable which is called as C. I want to take one more input variable C. Yes sir, to implement some output of full adder, let me take here C as an input, and I want to take the output of AB, and I want to take one XOR gate for these two. Here one XOR gate, and now what is the input of this is first XOR gate and then this is second XOR gate. What is the inputs of second XOR gate? One output is, we can say, A XOR B. This is what from first XOR gate, and then another output is from C. Sir, can I say that the output of second XOR gate is, yes, we can say that A XOR B XOR C? Yes. This is what the output. Of course, we can take a bracket here to understand better. No use of putting bracket also, because we can call it as A XOR B XOR C also, we can, no problem. This is what sum output. Sir, can you please just tell me, is it this sum output, whatever we are learning here, whatever we are seeing here, sum equal to A XOR B XOR C is the same output of full adder? Sum output here, sum equal to A XOR B XOR C? Yes. Which means 2 XOR gates I required to produce, sum output of full adder. Why? By using implementing of half adders. And now let us see how many number of other gates also required to produce the output of C out. We can say carry output. So here we can see AB plus A XOR B into C. This is what C output, which means what to implement, how to implement this carry output. Let us try to understand. Sir, we have already one AND gate here. Can I take one connection from this AND gate? Yes sir. Suppose if I can take one connection from this AND gate, what will happen, sir? Here this is A into B. And now I want to take one more connection from this particular AB. This is what here the output of first XOR gate is A XOR B. Can I take one output from this particular first XOR gate? Yes sir. You can take here. This is what one connection. Now I would like to take the output from here, and now this output is A XOR B, I can say. And now this is what another variable, this is C. Sir, can I take here C also? Yes. We need to connect one connection from, here C also. I want to take here the input is C. And now what kind of gates we need to use to produce this output? Let us try to analyze. Sir, here we have A XOR B, and now here AB, and now here C. What to do? Let us see. Sir, here first of all I want to connect this A XOR B into C. Sir, what kind of gate we need to use here to make multiplication? Here A XOR B into C, we just need to use one AND gate, no doubt at all. That means here I am taking connection, and then here also I am taking connection, and one AND gate I am using, so that the output is A XOR B into C. This is what output. And now coming to the final output, this is AB, and now this is A XOR B into C. And now to produce final output, what we need to take is, we need to use one OR gate between AB and A XOR B into C. So now between this gate and this connection, we need to use one more OR gate. Here let us try to draw the circuit. Here I need to use one OR gate, sir. One OR gate, so that this is one input and another input is AB, so that final output, we can say C out equal to AB plus A XOR B into C. So this is what carry output, C output. Sir, can you please just tell me, this is the circuit which we are using to implement the output of full adder. And now can you please just tell me how many number of XOR gates, how many number of AND gates, how many number of NOT gates, NOR gates are required here to implement full adder is. So now from this particular diagram, let us see here, by looking this diagram itself, here one XOR gate and one AND gate, which means one XOR gate and one AND gate. The combination of one XOR gate and one AND gate. Here the combination of this particular XOR gate and AND gate, we can say that this is what? One off adder. Yes sir. Off adder is nothing but combination of XOR gate and AND gate. And now coming to see here another XOR gate and another AND gate. Can I say that this is what also here combination of XOR gate and AND gate? Can I say that this is second AND gate and this is second XOR gate? Here combination of XOR gate and AND gate is also one off adder. Here also another off adder 2, and this is what? Off adder 1. And finally we are using one OR gate. One OR gate. Here the question is, how many number of XOR gates or how many number of off adders are required to produce the output of full adder? That is what the question that we need to concentrate. Sir, here the simple answer is we just need two off adders and one OR gate. One OR gate required to produce the output of full adder. The question is asking like that. Here the question is asking like that. Please note it down. And the question is asking like that. Let me take one question from this particular full adder implementation. This question is already asked in one of the PSUs. So that please note it down. Here, please note the question. Please note the question. This is what from one of the PSUs. How many number of, please note the question. How many number of, please note the question. Here the question is, how many number of off adders and other gates required to implement one full adder? This is the question. The options are given: A, 2 full adders and one OR gate. Option B, 2 off adders and one AND gate. Here option C, 2 off adders and one OR gate. And option D, 2 off adders and one NOT gate. So this is the question. And now we just need to minimize the possible identical answers when we don't know the answer actually and when we know the subject. Let us see here. The question is asking how many number of half adders, but the first option is given as, here there are 2 full adders. Here the first option is completely wrong. And coming to the second one, 2 off adders and one AND gate. One AND gate. And 2 off adders and one OR gate. And 2 off adders and one NOT gate. Sir, to produce final output, we not at all use a NOT gate in the combination of C out or sum. So we just need to eliminate option D even. And now the only logic is here we know that we are always in combinational circuits. We used to produce output. We used to connect the number of possible variables A, B, C, D or A bar B and then A, B, C bar, like this. the number of these combination of variables we will finally connect with plus symbol. We can say that OR gate. We are not at all using multiplication. After multiplication only we are using AND gate, OR gates. So that we just need to go for here. AND gate is not possible and final one is OR gate. This is the right answer. Which means by looking at this answer we can say that how many number of half adders, which means if question is asking single half adder or something like that, we can remove that option. Here two half adders, that means first option, first part is correct, and then second option other gates, which means the final output we always use to add, which means to add gates we are using OR gate. So that this is what the output. The answer is C. Please note it down.